All right, in this situation, we've got a pendulum, and it's being pulled back to a rotational angle of -25 and then let go. Now, after 1 second, so at 0 seconds, it's at 25 degrees. After 1 second, it's at -3.5. -3.5. After 2 seconds, it's at 24 degrees. So it's swung all the way over to the other side, almost. Or maybe it's there and back a little bit. After 3 seconds, it's at -16.4. So it's swung back. -16.4. At 4 seconds, -10.3, so that's squeezed in somewhere here. Degrees. At 5 seconds, it's actually all the way out at 25 again. And at 6 seconds, it's back to -10.5. So if x is the time in seconds, and f of x is the rotational angle of the pendulum. Okay, in this case, we've got a person who's breathing, and this is their lung, okay? And as they breathe in and out, at a regular interval as time passes, the lung gets wider and then less wide, wider and then less wide. It oscillates. So here's the information that we have, okay, for this person. At its lowest point, it's on an exhale, the air gets blown out, the lung goes in. That's at 5 inches, okay? And at its widest, on an inhale, it expands, gets a little bit wider at that point to 6 inches, okay? And we also know that this person, we timed it over a minute, and this person took 15 breaths. 15 breaths in that 1 minute, okay? So now, assuming this continues, this rate of breathing, oh, and when we started the timer, it was at its widest, 6, okay? So that's all we know. We know that when we started the timer, it was at its widest. This person is taking exactly 15 breaths, full breath. So from 6 is the inhale, and then exhale, inhale again. That's 1 breath, okay? 15 of those. It started out at 6. And that's the information that we have. All right, in this case, you've got a pie that you've been baking. You just took it out of the oven. You start the timer, and you're going to be counting it in minutes. So 0 minutes, the pie is 325. Now, after 5 minutes, the pie has cooled significantly down to 225 degrees Fahrenheit. These are. Okay, and then after 10 minutes, the pie has cooled down to 150 degrees Fahrenheit. And then after 15 minutes, it's cooled a bit more, down to 115 degrees Fahrenheit. And then after 20 minutes, it's down to 100 degrees Fahrenheit. After 25 minutes, it's down to 92 degrees Fahrenheit, and it continues to do this until 60 minutes later it's down to the room temperature, or very close to it, at 72 degrees Fahrenheit. So if x is the time in minutes and f of x is the temperature of a pie as it cools from out of the oven down to room temperature. All right, in this case we're in a desert here, and it is 6 in the morning. So 6 in the morning, we're starting our timer, and so that's hour 0. And the output is the temperature, all right? So the output, we're measuring the temperature. The sun's just coming up in this particular hour, and it's 85 degrees, 6 in the morning, okay? 3 more hours, right? So the clock moves over to 9 a.m., so that's 3 hours in. We're up to a 96 degrees. Okay, the sun is getting higher in the sky. Okay, it's getting warmer. Right? So the heat, used to be here, and now it's moved up. Okay, now noon, we're getting to the hottest part of the day. Noon, that's 6 hours in. We're up to 104. Okay, so the sun's up at its highest point, and we're at 104. It's higher. 9 hours later, now we're at 3 p.m. The sun's back down. It's cooled off a bit, and now it's 95. Okay. 3 more hours later, now it's 6 p.m. 6 p.m. The sun is starting to set down here. The temp is, not 6 here, this is 12. 12 hours later at 6 p.m. We're at 87. Okay. And then at 15 hours, the sun is now down, the moon is coming up, it's starting to cool off. 62 degrees, it's cooled off quite a bit. 18 hours later, we're at 58. Now we're in the middle of the night. 21 hours, we're at 62 again. And 24 hours later, we're back to 6 in the morning. The next morning, we're back at exactly 85 again. So assuming this cycle continues, right? We started at 85, 24 hours later, we're back at 85. Assuming that's going to continue for a number of days. X is the time in hours since we started it at 6 in the morning one day, and f of x is the temperature. Okay, in this example, we've got a room of sorts. Maybe it's a prison walls, and we've got a spotlight in the middle of that room. And currently it's facing in this particular direction, and we're measuring the luminous intensity along that wall. So right now, there is some light on this wall. I mean, even though the light's casting mostly on this wall, it's certainly based on reflection off walls. This is getting lit up some, but not as much as if it was shining directly on it, and more than if it was shining directly away from it. So right now, we're gonna start that timer, and this spotlight rotates, right? Okay, rotates like that. Right now, at 0 seconds, we have a luminous intensity here of 70 candelas, okay? Now, after 2 seconds, this thing's rotated. Maybe now it's facing something like that. So now we've got less light shining here. We're at actually 39, so a fairly significant amount less. At 4 seconds, now it's facing more or less the opposite direction of this wall. We are at 31 candelas. After 6 seconds, now we're facing kind of in this direction, still away. 55 candelas, we're starting to come back. At 8 seconds, we're more or less on this side wall here, so we're starting to come back, and we have 88 candelas. 10 seconds is, we're basically almost back to the front area here. We're at 100 candelas. 12, we're starting to get past it again. 79 candelas, and at 14 seconds, we must be back maybe up here somewhere, and we're at 46 candelas. So assuming this light continues to rotate in that fashion, x is the time in seconds, and f of x is the luminous intensity of the spot on that wall as the spotlight rotates over time. Okay, in this example, we've got a man throwing a gigantic oversized boomerang, and x is going to be the time after he starts to throw it, and f of x is going to be the distance that this boomerang is from the man. So at 0 seconds, right when they started, he's about to throw it, it's 0 feet away. He throws it, and after 1 second, this boomerang is now over here somewhere, okay? And that is at a distance of 40 feet away. 40 feet. After 2 seconds, it's over here, starting to kind of turn around, and apparently morph shape. Now it's at 50 feet. After 3 seconds, it's at 55 feet. At 4 seconds, it's turning around, and it's back to 50 feet. And at 5 seconds, it's back to 40 feet, and at 6 seconds, back to his hand, 0 feet. So if x is the time in seconds and f of x is the distance that that boomerang is from the man. Okay, this is called a piston and crankshaft. Notice that the bottom part here rotates. Okay, so that's a rotation. And the top part is just only changes distance. It's a straight up and down motion. So this is something that converts rotation into distance. Okay, so that's the kind of situation we're dealing with here. So the drawing is going to be in relation to that machine. Okay, in this situation, we're looking at the rotation of this crankshaft here. And right now, this would be considered 0 degrees. Okay, so when this is at 0 degrees, oh, and this piston, we're measuring the height of the top of the piston here. Right now, it's at 5.5 inches, 5.5 inches. Okay, so when it's at 0 degrees, it's at 5.5 inches. All right. Now, when this thing rotates down to here, which is negative 90, okay, negative 90, so we're at negative 90 degrees, it's rotating this way. This piston head gets pulled all the way down here, okay? And that's at 4. So negative 90 is 4 inches. You can imagine when it's over here, when this thing's cranked over to here to negative 180, it's going to be back to 5.5 inches. Okay. And then when it's cranked up, right, this direction, which is negative 270, that's when it's going to be at its highest, all the way up here at the top, 7 inches. Okay. So that's negative 270, and then at negative 360, that's the same as 0. So 5.5, and that's just going to continue. So if x is the amount of rotation of this crankshaft, and f of x is the height of the top of that piston,